Well, thanks for joining us for this session, which is William Penn Foundation's thinking and imagining about what the role of a farm would be in watershed sustainability in the future. This presentation is focused on the Mid-Atlantic region conditions here. We recognize conditions are different across the country, but we think that many of the concepts that apply here could also be applied elsewhere. But this one is specifically for conditions that we are aware of in our own watershed, our home watershed. So what should the farm of the future look like? We recognize the need for increased ecological function. We are particularly interested in as a foundation in the Delaware River watershed region in watershed outcomes, water quality maintenance and water quality improvement. But we also recognize that for this to work for farmers to be engaged, there needs to be an incentive for farmers to have increased profits, as well as and to become willing partners in solving the problems that we're facing. So we'd like to point out some of the challenges that we're aware of as we start thinking about how to resolve agricultural use within a sustainable watershed system. One of the biggest ones right off the bat is the idea that there's an incomplete cycle of nutrients regionally between the Midwest and the Mid-Atlantic. Grain comes in from imports from aggregators and used locally, fed to local animals. The waste from that grain feed stays here locally and contributes to resulting waste problems and pollution problems in local streams. And that creates this imbalance. So all the grain comes in, the waste stays here, pollutes locally, and becomes a local problem to solve. And there is no closing of the nutrient cycle between the Midwest and the Mid-Atlantic. We also want to recognize the significant challenges posed by watersheds in particular in terms of the upstream and downstream component. Most of our watersheds, where we have first and second order streams, and most of the areas that we are aware of that science tells us is effective to work in is in the first and second order streams where we do land protection and ag restoration. Most of the population centers in our local watersheds here on the East Coast tend to be located downstream on higher order streams where people inherit a lot of polluted water from upstream and also flooding problems from upstream due to impervious land cover. These population centers downstream are also where a lot of low-income and minority communities are typically found. And the problem is that creates a sort of political problem and a financial problem to solve, where you've got poor urban communities that are paying for chemically treated drinking water rather than paying to send money upstream to solve the problems at source that they're inheriting from upstream, especially when any of those upstream community areas are seen to be wealthier communities than the urban communities where the money's coming from to solve the problem. So that's another significant challenge. And then we've got the challenge of scale and land ownership and fragmentation, jurisdictional fragmentation in watersheds. Our watershed, the Delaware River watershed, is 13,500 square miles. We're also dealing with parcels in this watershed that average around 100 acres. So that makes for a heavy lift when you go out and try to talk one-on-one with landowners to do conservation practices. Also, layers of municipal regulation and state and federal regulations, many different kinds of jurisdictional levels across the watershed, and don't line up with the watershed, obviously. And finally, the NGOs themselves, who are our frontline partners in trying to help achieve conservation and watershed sustainability, have challenges as well. Many of them work only locally and not regionally, and most of them don't have any kind of a footprint that would work at a watershed scale. Having them work together to be effective and aligned is a collaboration exercise that we've been encouraging through our Delaware River Watershed Initiative. but it's an ongoing work in progress right now. We also have the challenge, of course, the eternal challenge of lack of resources. Government funding levels have never been high enough to solve watershed conservation problems and needs. And with the rise of COVID in the last year, we expect and anticipate that those dollars will become even less available. That will make the need for market-based conservation finance mechanisms even stronger in the future. Money that can be generated off of product sales and off of credits for ecosystem services that can provide perpetual funding sources for conservation in the future. That's a really critical need going forward. We also recognize that most of the early adopters, the altruistic landowners who have donated their land and potentially lost income to install things like ag BMPs, have really been maxed out at this point. And in order to reach the other 75 to 80% of landowners out there who would need to be engaged to achieve sustainable watershed conditions, we need to figure out a way to incentivize their engagement. We need to find ways to get them money to be involved in this process, to replace the income they would have got from the land that they've given over to the conservation benefit. So how do we resolve these things? There are solutions out there. We think we have a suite of integrated holistic solutions that work together to essentially resolve all of the issues that we've just described as challenges. We'll step through those now and try to explain them to you, and then maybe have a little Q&A as we go through or at the end. So here's a diagram of how all those different ecosystem service credits might play out on the ground. We've got credits potentially for air, which would be climate change, credits for water, both stormwater and actual water quality in the stream, credits associated with soil conditions, and then income sources from things like products that can be produced for sale from a conservation solution that serves both a conservation purpose as well as a income generating purpose. Very quickly, we've got things here like biochar, which come from working buffers, either clean or fertilizer based, that could generate carbon credits for air quality, for carbon sinks. There could be things that come out of the soil where they're introduced, biochar is introduced into the soil as a carbon sink. That would potentially be a carbon credit. And in the middle here, water potential ecosystem credits could take the form of credits for things on the East Coast, such as municipal stormwater permit credits. We already have some of this in play. These green color-coded boxes are things where we've already made investments to test out some of the concepts. And these are already in process ideas that are being researched. Another important concept which we'll look at is the way to administer all of these credits and all of these potential income sources could be through a sort of administrative managerial system called something like a revolving watershed fund, which we'll also review a concept with for you shortly. So we'll go into a little bit more detail here. Most of you probably at this point are familiar with the idea of carbon credits. That's playing out in our watershed with work that we're doing with the Nature Conservancy in Pennsylvania, primarily on forested lands in headwater areas, headwater streams. Mature forests could be preserved using carbon credits from the standing biomass of the actual forest itself. And that could generate income to preserve those forests for at least 40 years with voluntary carbon deals. The challenge that we face there is to aggregate those carbon deals into viable, feasible deals, which need to be between 1,000 to 2,000 acres in size in order to function adequately to cover the costs of the deal. That means 10 landowners, at least of 100 acres each, need to be in a carbon co-op in order to be able to use the system effectively. Some of the mechanical processes are being set by the Air Quality Board in California, which is where those carbon credits and voluntary carbon deals are being negotiated. So the terms of the deals need to be relaxed somewhat in order to enable some more flexibility around the idea of 10 plus landowners being locked into a carbon deal for 40 years. Things happen, people need to sometimes leave those deals. So we need some more flexibility about the way that people join and then can leave those deals, those carbon deals, in order for these to be more attractive for landowners to join. We're currently investigating and investing in how to relieve some of those tensions around those deals. There's also potential for soil to be a carbon sink. Carbon is caught up in soil, and if we can preserve the carbon in the soil or increase the carbon in the soil, there's possibilities of selling those credits, those carbon credits, and making funds to preserve agricultural land, for example, or even other forested soil land, prairie lands. I know that in the Midwest, they're doing some of this work in terms of root masses of prairies and the amount of carbon that's being able to sequester. To get back to one of the central concepts that we see as a potential solution here, we're calling it working buffers because it's a slightly broader term. Pennsylvania DCNR and PennVest in Pennsylvania have already tried to promote this through the concept of multifunctional buffers, but we tend to call them working buffers because we see the potential for doing more than just harvesting products from them. We see the potential for actually generating products through biomass production, for example, and integrating things like manure digesters into the system in a sort of more holistic solution than just simple product sales, things like elderberries and hazelnuts. So let me just describe this to you. The idea is that you would introduce a buffer that has the ability to generate income either from marketable products and also from credits, carbon credits primarily, but also stormwater credits downstream from municipalities. But while still assuring the conservation benefit is primary. So here we have the idea of product income from selling clean, what we call clean biochar that's produced from multi-stemmed coppicable shrubs that is a perpetual income source. You put that through a gasifier, you end up with a biochar that's clean, almost like an activated carbon, and you can then sell that product for use in things like green stormwater infrastructure systems, where you could potentially be using it to improve infiltration and potentially clean up pollution as that water is filtered through the soil. The soil credits here could come into play in terms of the carbon sink that you're putting with the carbon biochar back into the ground, and also obviously the carbon from the air credits for climate change that are currently in play for preserving headwater forests. And potentially downstream municipalities would pay for these green stormwater infrastructure credits in order to sort of meet some of their stormwater permits, the MS4 municipal stormwater permits that are in play right now in our region. The next opportunity is really to introduce a manure digester as well as a gasification system to make this work. And then you have the opportunity to create biochar that is essentially a slow-release fertilizer, a natural form of a slow-release fertilizer, has the same credit potential, has the benefit of removing the manure from the fields where we've got too much, and turning it into a product that is used in combination with the biochar as the fertilizer. The idea is that you would then sell this as a product, ideally back to the Midwest where the problem came from, and that you close that loop in terms of the nutrient cycle imbalance. And so you're making sales from the product, but you've also got the carbon credits as before, and you've reduced the load on the fields locally, which is polluting the streams. So that could be a definite possibility and solve many problems with one solution. And finally, the manure digester itself potentially could also generate carbon credits. It would definitely reduce the amount of non-point source pollution load on local streams. I'm not entirely sure that there would be any kind of soil health benefit from it directly, but certainly there would be heat and energy replacement. You would avoid spending money on heat and energy, or reduce your heat and energy costs if you could use a manure digester in the system in a sort of campus-like setting where you would be replacing heat and energy from the manure digester by purchasing, you wouldn't be purchasing external heat and energy anymore. So those are many solutions for a relatively simple concept. This is what it might look like in section, where, for example, you have an outer edge of filter zone, which might be warm season grasses. These are perpetually producing goods, and you can sell them either for things like at $6,000 an acre currently to stuff erosion control blankets, or they can actually be put through the gasification system itself, or used potentially in conjunction with a manure digester as well. The coppicable shrub zone is again a way of producing perpetual biomass that can feed the system. Hopefully you would use native shrubs, things like hazelnuts and alders that grow very well when coppiced on a rotational system. And then you have the inviolate stream buffer adjacent to the stream that serves the ultimate conservation purpose of protecting the stream itself. If you do these outer sections at the right scale with the right rotational harvesting, these will also serve to increase the zone of filtration before water gets to the stream. We are still investigating the scale that this needs to happen at within a watershed to make it both viable financially and also viable from a conservation perspective. So here are a few more diagrams that some of the students from PennPraxis provided to help illustrate some of the more expansive concepts of a working buffer. Here we have the stream corridor with different zones of available work area. Let's look at what that means. You've got the inner inviolate stream buffer itself, where no harvesting is allowed, obviously, and this could be anything from 15 to 35 feet, depending on the conditions locally. I will say that a helpful thing to think about is something the Nature Conservancy introduced, which is called the active river area, and it takes account of the topography, not just a fixed zone, fixed distance from a stream, the center line of a stream. And it's a useful concept, which includes things like, floodplains that are critical to ecosystem function for a stream corridor. We have zone 1, where there could be some hand harvesting of native shrubs and trees, likely to be wet conditions, probably seasonal harvesting only. Because of that, you'd want to go in when the ground was not wet, so that you avoid compaction and stuff like that. Kinds of things that you would use in this zone could be black willow for possible bioengineering use and sale, and some of the other native shrubs and trees that could be used for product sales. And maybe also potentially for foraging. We'll come back to that idea later when we talk at the end about the possibility of applying this at the New Bolton Vet Center. Zone 2, it would be the main managed woody zone, where you've got fast-growing shrubs, native shrubs ideally, and you could come in and harvest these periodically and on a rotational basis. And again, just to emphasize that this is at a scale to be determined for feasibility and also for conservation benefit. So this is an active area of research right now. Things that you could also grow in here could do double duty. You could have shrubs that were coppicable for biomass, but you could also have things that produce products at the same time, such as high bush blueberry, elderberry, hazelnuts, possibly even things like pawpaw if they're particularly good at being coppiced. And then the outer edge that we mentioned for grasses, something like warm season grasses, switchgrass in particular, is a good choice. The outer zone, again, I think this would be the sort of filtration system, mostly grasses and perennial wildflowers. The idea would be that if for nothing else, you could certainly sell this for additional biomass production, but you might also be able to sell this either for florals or, as we mentioned, there's a very strong market right now for erosion control sausages, where warm season grasses are replacing things like just regular straw in that system quite cost effectively and benefiting the farmer for that. There's also an opportunity to introduce lateral infiltration trenches into these systems. The outer one, the one closest to the farm, furthest away from the stream, would potentially be an active managed trench that would capture sediment annually and then be dug out, and the farmer could put that sediment back up onto his agricultural fields. That would be the first line of defense. But then anything that overtops that trench after the sediment has dropped out would potentially be able to flow down into a more permanent wetland trench where the runoff from the surface would be captured and water could be sort of polished to a higher quality and also infiltrated into the root zone of the riparian buffer downstream from it, or downhill from the watershed lateral trench, from the water lateral trench. So there's all kinds of ways that we can consider adding to these ideas of these multifunctional buffers. The potential is also there to have fences at different locations in the buffer to be able to control access to the buffer by livestock for perhaps browse purposes as well down the road. So there's a kind of a mix and match smorgasbord of opportunities of the way that you can design these multifunctional buffers for long-term benefit and income that needs to be researched and piloted. So another part of the idea of managing all of these various credits and product sales is that there could be benefits from having an overarching mechanism, an administration mechanism that we've been informally calling a revolving watershed fund that could manage all of these things. There would be some cost benefit from having multiple functions of watershed sustainability and conservation managed by the same entity, which could be a nonprofit entity in its own right. The idea is that whether you're producing income from products or whether you're selling credits, you would have this entity manage the process, manage the biomass production, manage the sales, manage the land rent to the farmers potentially. The idea here is that if you're doing quantification of things like environmental impact units that basically become the currency of the credit system for things like evaluating the benefit of ag BMPs, this mechanism could be the point of validating those quantification systems and then selling them to the potential buyers. They could also then also be selling the products, the elderberries, the hazelnuts, the biomass, and managing the gasification and the manure systems en masse for larger parts of the watershed. So that individuals don't have to do this. We need to sort of reach that scale and feasibility access and solution. So the idea is that there's enough of money in the system to pay the nonprofit managerial system to manage itself. And then any excess income can be put back into products on the ground, solutions on the ground, ag BMPs, land preservation upstream, and overcome that upstream, downstream geographic divide that we were mentioning earlier. And then the whole system starts again. Once you put more products, more solutions, more projects on the ground, those can be either sold or evaluated for credit. The credits can then be sold. The money goes back into the bank, and the whole thing keeps cycling around and around. And the idea is that we've got revolving funding for conservation, overcoming many of those geographic limitations that we were talking about previously. I just want to zoom in very quickly and note the opportunity for this clean biochar for use in green stormwater infrastructure installations in more suburban and urban areas, less to do with agriculture and more to do with those downstream opportunities. Clearly, biochar is a carbon product. If you incorporate it into the soil, you can potentially get carbon credits for that. Producing biochar may enable you to get carbon credits in the voluntary carbon market itself. The big opportunity here is in this section underwater, where using potentially clean biochar, which acts like activated carbon in the soil, theoretically could be helping to increase infiltration and improve the quality of water that is recharged into the ground. There could potentially be carbon clean water credits or stormwater credits here from the states involved. So that's, and then the sale of the product itself, as well as all the credits, would add just more money in the system potentially. So we think that there's real potential here for credits and product sales for green stormwater infrastructure coming off of these working buffers where clean biochar can be produced. So how does all of this relate to the farm of the future, and particularly to the new Bolton Vet Center? We've already spoken with the new Bolton Vet Center in the last year or so. The site that they have offers great potential to be a test site for all of these concepts. They have exactly the right conditions. They have the livestock. They have the watershed frontage for a working riparian buffer demonstration. They've already mentioned that they feel they want a manure digester or need a manure digester to deal with their on-site manure problems. Introducing a gasification system alongside that would allow us to really delve into these opportunities to demonstrate the full spectrum of solutions that a working buffer could provide. And also want to point out that University of Pennsylvania has sustainability goals that these kinds of solutions would help meet. University of Penn's Vet Center is also a research facility, an applied research facility, and is very well set to disseminate good agricultural solutions, not only locally, but regionally and potentially globally. So our information is here if you want to reach out to us. I will acknowledge Chris Kieran, my colleague, and also Jamie Bartolino, my colleague, for assisting with this presentation and being resources for us to have a conversation with going forward about these concepts.